let 1 minus 3i z be equal to 5, 1 plus I. Express z in the form a plus ib. So let's go on. Been given 1 plus 3i, z, that is being equal to 5, 1 plus I. Well, we can simplify this, and this is going to give us 1 plus 3i z, that would be 5 times 1, that would be 5, 5 times I, that would be 5i. To remain with z, we are going to divide both sides by 1 plus 3i, and so z gives us 5 plus 5i divided by 1 plus 3i. Now at this point we can conjugate. What is in the denominator, we multiply on top and down, so we just change the sign of the imaginary part, the portion containing an I, so it becomes now negative because it was positive. If it was negative, it would have become positive. So this is the conjugate of this when we just change the sign. So 5 times 1, that is going to give us 5. 5 times negative 3i, that is going to give us negative 15i. And then this times that, 5i times 1, that will give us 5i. 5i times negative 3i, that would be negative 15i squared. And now divided by, well, if you multiply a number by its conjugate, just get the first number, you square it, and then plus, get the second number, just the number in front of the I, not together with the I. Okay, that is a 3. Also square it. And so that is going to give us, where there is I squared, we can replace a negative 1. So that will be negative 15 by negative 1, which will be positive 15. Positive 15 can be added to a 5, and that is going to give us a 20. Then negative 15i plus 5i, that will give a negative 10i, and divided by 3 squared is a 9, 1 squared is a 1, so 9 plus 1 is a 10. So therefore z is 10 into 20 is a 2, 10 into negative 10i is an I. So z is 2 minus I in the form a plus ib. Find the conjugate of z, which is equal to 2 plus 3i over 5 plus I squared. So we've been given that z is equal to 2 plus 3i divided by 5 plus I squared. Now the first thing that we want to do is to work with what is in the denominator to simplify it. So the 5 plus I squared, this will give us, we get the first number, we square it, that will give us 25. And then multiply 2 by 5 by positive I, that will give us 10i. And then get the second number, square it, that will be I squared. So if we wanted, we would say 5 plus I, again 5 plus I. We can go with this, it will still give us the same value. Now we know that I squared is a negative 1. So that will be negative 1 plus 25, which will give us a 24. So this will be 24 plus 10i. And so z will be equal to 2 plus 3i divided by 24 plus 10i. Now at this point we can conjugate z. We multiply by the conjugate down and on top. So the conjugate of 24 plus 10i will be 24 minus 10i. We change the sign of the imaginary part, and this would be 24 minus 10i also. And so z will be equal to 2 times 24, that would be 48. 2 by that one there, 2 by negative 10, that would be negative 20i. 3i times 24, that is going to give us 72i. And then you have got positive 3i times negative 10i, that will give us negative 30i squared. Now multiplying a number by its conjugate, just get in the denominator, multiplying these two, just get the first number, square it, again get the second number, square it, don't get the I, just the number in front. So where there is an I squared, we can place a negative 1, that will be negative 30 times negative 1, which will be positive 30. And then positive 30 we can add to the 48 because it's also a number without any I. So that would be 78. Well, this one was supposed to be 72i, since okay, we multiplied that with that and then this by that. Yes, it's supposed to be a 72i because we multiplied 3i by 24. Okay, so we are saying there's an I here. Now negative 20i plus 72i, that is the same as 72 minus 20, which will be a 52i, and that will be now divided by 24 squared plus 10 squared, 676. So we can as well split this into 2, and that will give us z being equal to 78 over 676 plus 52 over 676, and then there is an I there, as we can see at that point. Now can 78 simplify further? Okay, so this further can be written as z is equal to 78 and 676 have got a common factor, and that will give 3 over 26. And then we've got 52 into 676, so 13, so that will be 1 over 13 I. 52 can go into itself once, 52 into there 13 times. Now the question is find the conjugate of z, which is this. So the conjugate of a number written as z with a bar on top is simply changing the sign of the imaginary part. So that would be 26. Because it is positive, it would now be negative 1 over 13i. So this is the conjugate that we are looking for. Find the modulus of negative 2 divided by 1 plus I. Well, the first thing to do for us to find modulus is we need to write it in the form a plus ib. So we're going to conjugate, multiply by 1 minus I on top, even down 1 minus I. This will give us negative 2 times 1 is negative 2. Negative 2 times negative I, that will give us positive 2i. And then since in the denominator I'm multiplying a number by its conjugate, get the first number squared, that is 1 squared, plus the number in front of the I is 1, also square it. So that gives negative 2 plus 2i divided by, this is of course 1 squared, it's not a 12. So that is 1 squared plus 1 squared, which is a 2. So that will give us negative 2 over 2 plus 2i over 2, which simplifies into negative 1 plus 2 into 2i is an I. Now we want the modulus. So modulus, we put it in bars like that. Okay. So the modulus of a number is simply getting that number, you square it and then square root. So get the first part, square it, and then the number in front of the I, that is the 1, also square it, and then we square root. 1 plus 1, negative 1 squared is a 1, positive 1 squared is a 1. So here it is the square root of 2. That's the modulus for this one. What of the second part? What would be the modulus of that one given? So we are talking of 2 plus I root 2 divided by 1 plus I. So we're going to conjugate to multiply by 1 minus I on top and down. So that is going to give us 1 time, so 2 times the 1 there, that is going to be 2. 2 times the negative I to be negative 2I. And then this one by that will be positive I root 2. And then this by that will be negative I squared root 2, and then divided by, in the denominator we're multiplying a number by the conjugate, so that will just be 1 squared plus 1 squared. Now we can see that where there is I squared we can replace a negative 1, and that will be negative times negative 1, so this portion is going to become positive. And then we have got also this one which is positive, so that will be 2. We bring this one also without an I because we've replaced where there was I squared. That will be 2 root 2. This is the real part. And then we have got also these 2, so we can write it as plus. We'll start with the root 2 which is positive, and then we write a negative 2 there. We can put the I outside. Okay, and then that will be now over 1 squared of plus 1 squared is a 2. So we can as well write this as 2 plus root 2 over 2 plus root 2 minus 2 over 2, and then there's an I there. Now I want to find the modulus of this. We'll get the first number, we square it. The first number we have is 2 plus root 2 over 2. We square it. And then the second one is root 2 minus 2 over 2. Also square it. And then square root that. Now 2 plus root 2 squared, this will give us, we get the first number, we square it, that will be 4. And then 2 times 2 times root 2, that will give us 4 root 2. And then get this one, you also square it, that will give us a 2. Root 2 squared is 2. So add this and that is going to give 6 plus 4 root 2. So just on top here it is giving 6 plus 4 root 2, and then in the denominator 2 also is squared, that will be a 4. And then you've got the other side, root 2 minus 2 squared. We get first the first number, we square it. Root 2 squared is a 2. Multiply this by that, that will be a negative 4 root 2. And then square also this one. Negative 2 squared will be a positive 4. And so this will give us 2 plus 4, which is a 6 minus 4 root 2. So even this side we've got 6 minus 4 root 2. And then that is also divided by 2 squared, which is a 4. And then remember the whole of this thing is being square rooted. So actually what is inside there we can add. Because they've got the same denominator, that would even make things much simpler. So just add this and divide by 4 since the denominator is the same. So we're going to have the root of 6 plus 4 root 2, and then plus 6 minus 4 root 2, and then everything divided by 4. So we see that this and this will cancel out, so we will remain with 6 plus 6, which is a 12, and then divided by a 4. Now 4 into 12 is a 3, so that would be root 3. So this is the modulus of this one then.